The morning of November 20th, 1943, arrives at Betio Island in the Tarawa Atoll with a terrible clarity. The beach ahead bears the scars of what will become the bloodiest assault in Marine Corps history. Shell craters and twisted metal litter the coral sand near Red Beach, where Corporal William Dean moves methodically through his final preparations. His M19-119A4 machine gun sits mounted on its tripod, a weapon both elegant and deadly. 250 rounds of .30 caliber ammunition rest in cloth belts, waiting. Around him, other gunners perform the same ritual, checking feeds and functions while coral dust swirls in the smoke-filled air. The ground beneath their feet pulses with concussion. Then it comes, a sound that will echo through the nightmares of every survivor who hears it. From out of the haze, hundreds of Japanese soldiers surge forward in a counterattack born of desperation. Their Type 92 machine guns bark in that peculiar rhythmic pattern, a slow tock-tock-tock that gives the weapon its grim nickname, Woodpecker. The Japanese crews strain under the weight of their massive guns, feeding 30-round metal strips into the mechanisms as quickly as their hands can move. Against them, the American M1919s answer with something entirely different, a continuous, almost mechanical stream of fire that seems to have no beginning and no end. What unfolds in the next hours will prove something fundamental about warfare. That American firepower doctrine has evolved into something that Japan's industrial approach simply cannot match. The M1919 Browning will become the answer to a question Japan never anticipated. The weapon arrived in the Pacific Theater as the practical evolution of proven technology. John Moses Browning, the legendary firearms designer, had taken his water-cooled machine gun from the First World War and reimagined it for modern combat. He removed the water jacket, simplified the cooling system with air circulation instead, and created something that could be carried by two men and deployed almost anywhere. The M19-919 fired the potent .30-06 Springfield round, each 150-grain bullet screaming from the barrel at 2,800 feet per second, at a rate of 400 to 600 rounds every minute. A standard cloth belt held 250 rounds, but gunners could link multiple belts together for seemingly endless ammunition supply. The mathematics of destruction were brutal and straightforward. Each .30-06 round carried enough velocity and energy to kill at ranges exceeding 1,500 yards. But the real genius of the M1919 lay not in raw power, but in practical design. The weapon weighed only 31 pounds, and with its 14-pound tripod, the entire system came to just 45 pounds, light enough for a two-person crew to move rapidly across a battlefield. The design philosophy rejected perfection in favor of reliability. Those loose tolerances that some critics dismissed as crude actually prevented the weapon from jamming when sand, mud, or carbon deposits fouled its mechanisms. The recoil-operated belt-fed system remained simple enough for teenage Marines to master quickly, yet robust enough to fire thousands upon thousands of rounds without failure. By 1944, American factories had produced nearly 400,000 M1919 machines across all versions. That production represented a massive industrial achievement. General Motors' Saginaw steering gear division alone manufactured over 200,000 units. Buffalo Arms Corporation and Rock Island Arsenal contributed tens of thousands more. This distribution of manufacturing meant American forces in the Pacific possessed reliable, standardized weapons at every organizational level. The Marine Corps equipped each company with two M19-119A4s deployed through the weapons platoon. By war's end, each Marine division wielded hundreds of these guns, creating overlapping fields of fire that no infantry assault could survive. Japan's Type 92 heavy machine gun stood in stark contrast to everything the M19E19 represented. Named after the Japanese imperial year 2592, which corresponded to 1932 on the Western calendar, the Type 92 represented Japan's effort to modernize their automatic weapons using the French Hotchkiss design as a foundation. The weapon was gas-operated and air-cooled, fed by metal strips holding 30 rounds of 7.7 by 58 mm ammunition. Despite firing a heavier cartridge than Japan's earlier weapons, The Type 92 suffered from design flaws that would prove catastrophic in actual combat. It fired approximately 450 rounds per minute, but those 30-round feeding strips created a critical limitation. Crews spent more time reloading than shooting. The complete system with tripod weighed 122 pounds, 77 pounds heavier than the M1919A4's combined weight of 45 pounds. This weight came from over-engineering. The Japanese had built the weapon with excessive precision that actually harmed its battlefield effectiveness. The Type 92's most fatal flaw was its ammunition oiling system. An internal pump lubricated cartridges as they fed into the chamber, a solution meant to handle extraction problems without proper primary extraction. In theory, elegant. In practice, the oil attracted dirt, sand, and debris in the tropical conditions of the Pacific Islands, causing frequent and devastating jams. The precisely fitted parts that might have impressed observers during peacetime demonstrations became liabilities under combat stress. Unlike the M1919's generous tolerances that accepted battlefield contamination, the Type 92's tight tolerances meant even small amounts of debris could render it inoperable. The metal feed strips themselves presented another problem. These 30-round carriers were fragile and easily bent or damaged during transport and combat. Loading each strip consumed precious seconds during which the gun could not fire. American gunners, by contrast, linked multiple cloth belts together, creating continuous feeds of 500 rounds or more without interruption. The Type 92 featured another quirk that complicated combat effectiveness: an offset sight mounted to the right rather than centered, which made training difficult and reduced accuracy during rapid engagements. Japan produced approximately 45,000 Type 92 heavy machine guns across its entire production run from 1932 to 1945. Tokyo Gas and Electric Company, along with Hino Motors and Hitachi, manufactured these weapons with meticulous attention to standards suited for peacetime. Each Type 92 required extensive hand-fitting of parts, making production expensive and time-consuming. The United States manufactured nearly 390,000 M1919 machine guns during World War II alone, almost 9 times Japan's total output. This disparity revealed the fundamental industrial mismatch between the nations. The production philosophies differed dramatically. American manufacturers applied automotive industry techniques to weapons production. General Motors' Saginaw division brought assembly line methods perfected in automobile manufacturing to machine gun production. Parts were completely interchangeable between manufacturers. A gun produced by Buffalo Arms could use components from Saginaw or Rock Island Arsenal without modification. Japanese Type 92s frequently required individual fitting of replacement parts because the handcrafted production process meant components from one gun might not fit another. By 1944, American factories produced more M1919s in a single month than Japan produced Type 92s in an entire year. At Henderson Field on Guadalcanal, the night of October 24, 25, 1942, demonstrated why reliable automatic weapons mattered so much. While Sergeant John Barcelona earned his Medal of Honor manning water-cooled M1917 guns, M1919A4s proved their worth throughout the Marine perimeter. When the Sendai Division attacked, Marines with air-cooled M1919s repositioned their lighter weapons quickly, moving to threatened sectors while the heavier water-cooled guns remained fixed in place. Private First Class Mitchell Page, who also earned the Medal of Honor that night, described the M1919's advantage. The air-cooled 30 caliber guns were our mobile reserve. When the Japanese broke through, we could grab the gun and tripod and run to plug the gap. At Tarawa in November 1943, Marine machine gun crews demonstrated the M1919's versatility in amphibious operations. Despite being soaked with seawater during the landing, the weapons quickly entered action. Corporal James Russell of the 2nd Marine Division destroyed multiple Japanese positions with his M1919A4, advancing the gun by hand across the coral-strewn battlefield. The gun never quit, Russell testified later. We'd dump water from our canteens on the barrel to cool it, wipe the sand off the belt, and keep firing. We burned through 10 boxes of ammunition, 2,500 rounds, and never had a stoppage. The Japanese Type 92s defending Baitio Island, meanwhile, suffered constant malfunctions as coral dust mixed with their oiling systems. The Battle of Saipan in June and July 1944 provided perhaps the most dramatic proof of American machine gun superiority. During the massive Banzai Charge on July 7th, when 4,000 Japanese soldiers attacked American positions, M1919 crews from the 27th Infantry Division created interlocking fields of fire that transformed the assault into slaughter. Sergeant Thomas Baker's M1919 crew fired continuously for 6 hours, case after case of ammunition feeding through the gun. We had spare barrels ready, his assistant gunner Carl Morrison recalled. When one got too hot, we'd swap it out in 10 seconds and keep shooting. The Japanese just kept coming, and we just kept killing them. Our gun must have dropped 200 of them. On Peleliu in September 1944, the M1919's reliability in extreme conditions became legendary. Marines fighting in 115-degree heat discovered that while Japanese Type 92s seized from thermal expansion of their precisely fitted parts, M1919s continued functioning. Corporal Sterling Mace observed, "The Japanese woodpeckers would fire a strip or two, then go silent, jammed again. Our 30 caliber guns just kept hammering away. We knew we had fire superiority, and that gave us the confidence to keep advancing." The Battle for Manila in February 1945 showcased urban warfare, where mobility proved decisive. Marine and Army units equipped with M1919s could rapidly reposition their weapons from building to building, window to window. The 45-pound total weight meant a two-man team could move with the complete system intact. Japanese Type 92 crews, burdened by 122 pounds of weapon and mount, were essentially static once positioned. Lieutenant Colonel John Sheeson noted, "In city fighting, the ability to shoot and move was everything. Our machine gun teams could fire a belt and relocate before Japanese mortars could target them. The enemy's Type 92s were death traps. Too heavy to move quickly, they became fixed targets." The M1919's development emerged directly from First World War experience and interwar innovation. The original M1917 water-cooled Browning had proven highly effective in France, but military planners recognized the need for a lighter, more mobile weapon for the mechanized warfare ahead. In 1919, Browning modified his design to use air cooling, creating a weapon that could be mounted on vehicles, carried in aircraft, and deployed by infantry. The Army Ordnance Department spent years perfecting the design through systematic testing and refinement. This development process reflected American military philosophy: extensive testing, incorporation of user feedback, and continuous improvement. Between 1919 and 1936, when the M1919A4 was finalized, the weapon underwent dozens of modifications based on troop trials. The barrel was strengthened, the feed mechanism simplified, and the tripod redesigned for lower profile and reduced weight. Each change came from practical field experience rather than theoretical engineering. The 30-06 Springfield cartridge, standardized in 1906, had proven itself through 2 decades of use as an ideal military round, balancing power, range, and controllability. Japan's Type 92, conversely, represented an attempt to copy and improve foreign designs without fully understanding modern warfare's requirements. Based on the French Hotchkiss machine gun that Japan had licensed in 1905 during the Russo-Japanese War, the Type 92 incorporated refinements that actually degraded combat effectiveness. Japanese military experience had been primarily in China against poorly equipped forces, where the Type 92's accurate single shots and short bursts proved adequate. They failed to anticipate the volume of fire needed against well-equipped American forces. The Japanese obsession with precision manufacturing reflected samurai traditions, valuing individual craftsmanship over mass production. Each Type 92 was essentially hand-built, with parts carefully fitted by skilled workers. This approach worked for producing small quantities of rifles or swords, but proved disastrous for military equipment needed in large quantities. The oil pump system, added to compensate for the lack of proper primary extraction in the original Hotchkiss design, showed Japanese engineers solving a mechanical problem without considering battlefield practicality. Japanese documents captured during the island hopping campaign revealed growing awareness of American firepower advantage. A diary recovered from a Japanese officer on Saipan noted, "The enemy's machine guns fire continuously without pause. Our Type 92s must stop to reload every 30 rounds, while the Americans seem to have endless ammunition. We cannot advance through their fire. One American gun does the work of 5 of ours." Another report from Guadalcanal stated, "Enemy automatic weapons create a solid wall of bullets. Our woodpecker cannot compete with their sustained fire. They have removed the human element from killing." The weapon was fundamentally mechanical. Its power to break spirits was absolutely devastating. American GIs called them lawn mowers when they talked about the machine gun positions the Japanese were defending. That nickname came from the way those M1919 guns could shred advancing soldiers with the precision of a cutting blade. American machine guns rattled off their rounds with a steady, relentless drumming sound, utterly different from the slower, more deliberate tok-tok rhythm of the Japanese Type 92. That distinctive American chatter became something Japanese troops learned to dread before any attack even started, sapping their courage before the first bullet left the barrel. A Japanese military training document discovered in 1944 made this crystal clear, stating that enemy firepower had to be overwhelmed through nighttime raids and hand-to-hand combat, the only way to nullify what the Americans had in sheer firepower. Lieutenant Hiroaki Samashima was taken prisoner during the fighting on Luzon and gave soldiers who interrogated him a detailed account of just how badly the Type 92 performed. He described knowing full well that the American gun outmatched theirs in almost every way. The oil pump constantly gave trouble. When fighting in jungle heat and moisture, oil would thicken into something resembling glue, collecting dirt and plant residue until the whole system gummed up. So much time went into cleaning the weapon that actual firing felt secondary. The ammunition strips themselves were fragile, bending without much force, and each one held just 30 rounds. While Japanese crews were reloading, the Americans would gun down half their soldiers. Japanese soldiers had a nickname for the American weapon too. They called them Hitler's zippers because of that distinctive sound it made, like a zipper sliding open, except far more frightening. Japanese military documents unearthed after fighting ended, particularly those from Kira Naval Base, revealed the military's own assessment. The conclusion was blunt. The Type 92 heavy machine gun simply couldn't compete against American forces. The M1919 series had won the battle for firepower in every single firefight. Improvements to the Type 92 just couldn't happen because there simply wasn't the manufacturing capacity available. The answer they settled on was courage. Soldiers would just have to overcome the mechanical disadvantage through bravery. American M1919 manufacturing, by contrast, kept turning out reliable weapons month after month, all through the war, with production climbing from hundreds of units to thousands per month. Whether parts came from Saginaw or got stamped out at Buffalo Arms or Rock Island Arsenal, they all fit together perfectly. This meant field repairs could use components from any factory, or guns could even be salvaged for spare parts from damaged ones sitting nearby. The specifications stayed rigid, and testing remained brutal to ensure nothing slipped through. The actual production method, designed with mass manufacturing in mind, wound up making the guns stronger by creating slightly looser fitting pieces and cutting out complicated, unnecessary pieces. The assembly lines pushed through with mechanical precision. Over at Saginaw, workers who'd been putting together car steering columns were given new instructions on how to assemble machine guns instead. The company borrowed everything from car manufacturing, from the specialized equipment to the organized assembly lines to having workers focused only on specific narrow tasks. These people would perform the same steps again and again, reaching speeds and consistency that handcrafted work could never achieve. By 1943, Saginaw's single facility was churning out 10,000 M1919s monthly, exceeding Japan's entire annual output of Type 92s. The Type 92 went the opposite direction as the war dragged on. Quality kept declining. The earliest Type 92 weapons, made by Tokyo Gas and Electric, came out looking magnificent, with deep blue protective finishes and components fitted together with real precision. This company's background making industrial machinery before the war showed in how beautifully these guns went together. When 1944 came around, every compromise imaginable appeared in production. Visible machining marks stayed rough, gun sights became simpler, and the metals themselves got worse. As Japan ran short of raw materials, newer Type 92s started using replacement materials that couldn't handle the strain, breaking under the stress of combat. Weapons recovered in 1945 showed cast steel being used where better iron used to go in less critical spots, wooden grips taking the place of steel on various adjustment mechanisms, and simplified components that jammed constantly. The oil system that already gave problems became even worse as production precision deteriorated. Later oil pumps delivered either too much oil, drowning the system and collecting dust and dirt, or far too little, which meant the gun couldn't extract cartridges properly. American intelligence people who examined captured Type 92s from the war's final months concluded that these weapons were barely functional without a complete overhaul. Japanese command's own quality inspectors kept rejecting higher percentages of fresh weapons. Yet the desperate situation meant even broken equipment went to fighting troops. Americans manufactured 30 ASIO-6 ammunition on a scale that seems almost unbelievable, with absolute consistency across everything produced. Shells made in Denver, St. Louis, Salt Lake City, or anywhere else across dozens of factories would work perfectly in any M1919 anywhere. Pacific Forces got constant ammunition shipments in containers that kept moisture away, something that saved the ammunition from the rust and decay that destroyed Japanese rounds in the tropical climate. American production hit 10 billion rounds annually by 1944, providing enough ammunition for every machine gun to keep firing continuously. The weapons themselves kept improving, and so did the ammunition. Armor-piercing M2 rounds could punch through Japanese blockhouses and even bring down aircraft. Tracer rounds used for night operations came in several types. Standard red tracers for marking targets, dim-burning tracers for hidden positions, and delayed action tracers that wouldn't start burning until 100 yards away, protecting the shooter's location. Incendiary rounds worked against enemy planes and ammunition dumps. The specialized API rounds combined the penetration of armor piercing with the destructive power of fire. Late in 1943, the M1919A6 variant came out featuring a shoulder stock, carrying handle and ammunition box mounting system for easier movement and deployment. While 32 pounds without the tripod made it heavier than ideal for a light machine gun role, it gave American forces new tactical possibilities. Pacific Marines developed their own field-made improvements and adjustments. The famous Basilone grip, a handle made from wire and wood that could be clamped to hot gun barrels for moving them safely, was invented by John Basilone, drawing on what he learned fighting at Guadalcanal, and later the military standardized it for wider production. Marines also tried out different mounting systems that would allow gunners to fire from the shoulder while moving forward, though combat experience showed these weren't very practical. More useful were improvised anti-aircraft setups created from whatever scrap was available, letting M1919s engage low-flying Japanese planes. Tank crews would weld extra M1919s onto the sides of their vehicles to provide additional defense against Japanese soldiers attacking on foot. The M1919's straightforward design meant these kinds of modifications needed only basic tools and didn't require specialists to accomplish. The Japanese, meanwhile, continuously struggled to supply their troops with enough 7.7mm ammunition for the Type 92. This special cartridge, with its semi-rimmed design, needed very precise manufacturing, becoming harder and harder to produce as American submarines cut off supply ships and B-29s destroyed production facilities. Different factories made at least 4 separate versions of 7.7mm ammunition that couldn't be used interchangeably, creating supply headaches. The 30-round strips deteriorated easily. Salt water corroded them until they wouldn't feed, while impacts bent them into unusable shapes. The American M1919's cloth ammunition belts could be connected together without limit, but each Type 92 strip was a separate unit just waiting to fail. Japanese industry had no flexibility for making improvements. The Type 92 that appeared in fights around Guadalcanal in 1942 was essentially the same weapon fielded in the last battles of 1945. Nothing got fixed about the oil pump that constantly gave trouble, the fragile feed system, or how heavy the gun was. Japan's already struggling factories couldn't manage changes that would mean stopping production and retooling everything. Even basic improvements like drain holes for water or larger trigger guards to fit gloved fingers never got implemented. American machine gun teams trained hard before shipping out to war zones. The M1919 was brilliantly uncomplicated. Pull the charging handle back twice to ready it, load the ammunition belt from the left, and press the trigger. Swapping out a hot barrel took just seconds using an asbestos glove, though it meant opening the top cover, which was still much easier than how other countries designed their guns. American tactics focused on putting out massive amounts of fire with straightforward, dependable equipment. Gun crews worked as teams, where assistant gunners kept ammunition flowing and handled cooling the barrel while gunners focused on maintaining fire. The instruction emphasized useful field ability rather than parade ground precision. Crews drilled until fixing jams became automatic, muscle memory they could do in their sleep. They learned to know a malfunction just by hearing it happen. Figuring out shooting distance, adjusting where their rounds would land, and moving the gun up and down or left and right became second instinct. What mattered most was the lesson to fire and then move. Shoot quick bursts and reposition before the enemy mortars could find their location. The M1919's 45-pound weight made this possible. Gunners could grab their gun and its support frame and run to a new spot. American tactics also created superiority by coordinating multiple guns. Machine guns worked as pairs or groups where their firing angles overlapped, forming killing zones enemies couldn't survive crossing. The guns got positioned so they could protect one another, and if one got jammed or needed a barrel swap, the others would shoot faster to make up the difference. This organized approach to automatic weapons multiplied what each gun could accomplish. Japanese Type 92 crews needed intense training just to keep their guns running at all. The oil pump needed exact adjustments for how hot it was outside and how humid. Cold weather could make oil congeal and turn thick. Hot weather with insufficient oil meant the gun would jam up. The 30-round strips required careful loading, or the feed lips would bend and ruin the whole thing. The sighting system needed constant fine-tuning because different ammunition batches needed different adjustments. Japanese tactics prioritized precision shooting over volume, with Type 92 crews trained to shoot short, focused bursts at specific enemies rather than keeping up constant suppressive fire. This different approach to warfare became catastrophic. Japanese gunners learned to make their ammunition count, carefully choosing what to shoot at and firing only when certain. It made sense given how little ammunition they had and how long reloading took, but it stood no chance against the American way of fighting. Though really, Americans weren't throwing soldiers at guns in endless waves. Americans threw firepower. When a Japanese Type 92 team was methodically aiming at submarines, 3 or 4 M1919s would simply annihilate their position through overwhelming concentrated shooting. The M1919 became something of a legend among men who fought in the Pacific. Veterans told stories of guns that kept firing even after being buried under sand, dunked in seawater, or covered in volcanic ash from Iwo Jima's terrain. Those loose tolerances that some complained made the gun less accurate really meant it could work even when packed with grit and filth, giving it a genuine advantage in Pacific fighting. Marines described M1919s that fired for hours without stopping, while crews dumped water from their canteens on the barrels, trying to keep them cool enough to keep shooting. One story from Okinawa tells of an M1919 that got hit by a Japanese artillery shell and thrown off a cliff, dropping 30 feet onto jagged rocks below. Someone found the gun, put a new tripod under it, and it kept firing through the rest of that campaign. On Guam, another M1919 came out of a swamp where water had covered it for 3 full days. After getting cleaned and re-oiled, it fired without a single problem. After-action reports confirmed these accounts, building trust in American gunners who knew their equipment would hold up when it mattered. The M1919's lack of complexity meant fewer things breaking. With just a handful of moving parts, the bolt, barrel, and feed mechanism, the chance of failure dropped dramatically. Because the gun relied on recoil to cycle, as long as ammunition kept feeding, the weapon kept firing. Even guns that were worn out and had excessive space between parts would still work, though shooting straight might suffer. Keeping it functioning required just basic cleaning and lubrication, using whatever oil was available, motor oil, cooking oil, or even coconut oil when desperate times called for it. The Type 92's reputation went exactly the opposite direction. American Marines got to know that particular sound a Type 92 made when it jammed and stopped firing, and they'd use those silent moments to charge forward or relocate themselves to a better position. The oiling mechanism intended to make the gun reliable ended up being its most serious liability. Fighting in the humid jungle terrain of Guadalcanal and New Guinea, moisture would mix with the oil, along with fallen leaves and plant material, creating a thick, pasty sludge that would freeze the mechanism completely. Out on the coral atolls like Tarawa and Palau, fine sand particles would combine with oil to form a grinding compound that ate away at the precisely machined parts. Soldiers who took apart captured Type 92s said these guns were practically destroyed without hours of intensive work to restore them. Even when thoroughly cleaned and maintained correctly, they demanded constant supervision just to stay operational. The feed strips would corrode in the humid Pacific air until strips literally fused together and wouldn't advance ammunition. The oil pump would become clogged with sand and debris, demanding complete disassembly just to get it running again. Those precisely engineered parts would lock up from the brutal heat, refusing to move. When American military intelligence ran the numbers, they discovered something startling. The Type 92 needed 5 times more maintenance work than the M1919 simply to keep firing. The Battle of Okinawa from April through June 1945 would become the ultimate proving ground for these two machines. American crews had spent 3 years learning their craft across the Pacific, refining tactics through countless engagements. The M1919 operators moved with practiced precision, their overlapping fields of fire creating a blanket that made any Japanese assault feel like charging into a meat grinder. The fighting grew so intense that machine guns blazed almost without stopping for entire days and nights. During the massive Japanese push of May 4, 1945, American gunners faced waves of soldiers attacking in formation, more bodies than anyone had seen before. Men from the 96th Infantry Division kept their triggers squeezed for over 12 hours straight without a break. Staff Sergeant Beaufort Anderson watched his team burn through 30,000 rounds in a single night. They cycled through 6 barrels, wearing each one out, yet the gun never jammed, never hesitated, never failed. "We just kept feeding those belts in and swapping the hot barrels," Anderson remembered later, "and the gun just kept firing. The bodies piled up so high in front of us they blocked our view, so we had to shoot through them." The Japanese soldiers operating the Type 92s showed remarkable courage, but their weapons held them back. Here's where the difference mattered most. When American guns needed fresh ammunition, Japanese crews couldn't keep pace. Those 30-round strips emptied in seconds during heavy firefights, leaving gunners scrambling to reload while bullets cracked past their heads. When Type 92s did manage to hit something, the effect seemed almost small compared to the overwhelming streams from American guns that could sweep entire positions clean in moments. The cave systems that defined so much of Okinawa's fighting showed another M1919 advantage. Its relatively light weight meant that soldiers could carry it deep into those dark tunnels, maintaining firepower in spaces where most weapons became useless. That Japanese gun, weighing 122 pounds, might as well have been cemented in place in those confined quarters. After the battle, American reports told a grim story. Soldiers found abandoned Type 92s scattered throughout the caves. Crews had simply left them behind when positions collapsed, unable to move them in time. Many weapons lay there with seized mechanisms and snapped feed strips strewn around them, silent testimony to crews making their final stand. One statistic from Okinawa stood out. American forces gathered more than 200 Type 92 machine guns from the island. Of those, only 12 actually worked. The rest had jammed during battle, been destroyed by their own crews rather than captured, or were so worn out that repair was impossible. Meanwhile, M1919s that had been firing continuously since Guadalcanal 3 years earlier still ran reliably. When the war ended, the production numbers painted the full picture. The United States had built nearly 390,000 M1919 machine guns in various models. Japan had managed barely 45,000 Type 92s. That meant American forces had roughly 9 times as many automatic weapons. American soldiers could pour ammunition downrange without worry, knowing supplies would never run short. Japanese troops had to count every round, knowing replacements might never arrive. The M1919 went on firing through Korea, Vietnam, and countless other conflicts. Allied nations kept using it well into the 1990s. Some M1919s converted to NATO ammunition still see service today. That gun influenced machine gun design worldwide, with its belt feed system and quick barrel change becoming standard features other nations copied. The M60 that eventually replaced it kept much of Browning's original genius. The Type 92, flawed as it was, earned respect from American forces for the bravery of the men firing it. Captured weapons became trophies, though few soldiers understood just how inferior they really were. Veterans brought them home and showed them at Bond rallies stateside, pulling out those awkward feed strips and explaining the complex mechanism to amazed crowds, always emphasizing American technical superiority. Strangely, many of those trophy guns survive in better condition today than they ever knew in combat. Collectors maintain them with the constant care they demand. American ordnance experts who tested them after the war reached clear conclusions. Even in perfect conditions with flawless maintenance, the Type 92 simply couldn't match the M1919's ability to keep firing. The oil pump design was fundamentally broken for military purposes. Those feed strips represented obsolete technology. The excessive weight made the weapon tactically rigid. Their final assessment was blunt. The Type 92 was built for peacetime, not for modern war. These two weapons represented far more than just different designs. They revealed fundamental differences in how nations approached manufacturing, in their military thinking, and in their understanding of what modern combat actually required. America emphasized mass production, standardization, and overwhelming firepower delivered in volume. The M1919 came from a design philosophy that automobile companies could manufacture it. Teenagers with minimal training could maintain it. Factories could produce them in staggering numbers. This same approach spread through every part of American war production. The goal was quantity with acceptable quality, not perfect weapons in limited numbers. America's already massive industrial base grew even larger to serve military needs. The same facilities that built automobiles could build machine guns using the same methods and workers. Production could scale up quickly and continue indefinitely. Standardized interchangeable parts meant logistics simplified dramatically. Any part fit any gun. Any ammunition worked in any weapon. This uniformity multiplied combat effectiveness by ensuring guns stayed in action. Japan's approach came from a different tradition, one that valued individual skill over industrial power. The Type 92 reflected this philosophy in its precision manufacturing and emphasis on accuracy rather than volume. Those traditions of individual craftsmanship adapted poorly to industrial warfare. The complex oiling system and feed strips showed a fundamental failure to recognize that reliability in combat mattered more than performance during tests. The weapon's weight and complexity revealed a basic misunderstanding of what modern fighting actually demanded. Mobility and firepower outweighed precision. This gap rippled through combat across the entire Pacific. American soldiers believed in their weapons, and that confidence shaped how they fought. Men would hold position during Japanese charges, trusting their M1919s to do what was needed. They could attack aggressively, knowing their machine guns could pin down any enemy position. That confidence fed on itself. Aggressive tactics worked because firepower was superior, which reinforced aggressive doctrine. Japanese forces faced the opposite psychology. They knew their Type 92s couldn't match American weapons, so they turned to increasingly desperate attacks. Those suicide charges that marked the war's final phases came partly from recognizing they couldn't win shooting matches against superior American firepower. When you can't outshoot your enemy, the only remaining option is getting close enough that firepower stops mattering. This tactical desperation cost enormous casualties that hastened Japan's final collapse. The implications went beyond weapons themselves. America's ability to mass-produce standardized equipment meant unlimited supplies of ammunition, spare parts, and training materials. Japan's artisan methods meant each gun differed slightly. Each needed specialized parts. Each demanded individual attention. This complexity cascaded through the entire logistics system, creating impossible burdens on a supply chain already straining to the breaking point. Back on Saipan on July 7, 1944, where our story began, the pattern repeated itself. Massive Japanese formations charged straight into American machine gun fire. By this stage of the war, though, the outcome wasn't really in doubt. M1919s firing 400 to 600 rounds per minute from 250-round belts simply overwhelmed Type 92s, struggling at 450 rounds per minute from 30-round strips. The mathematics left no room for argument. American guns could spray 10 times the volume of bullets in any given time frame. A single M1919 could fire continuously for a full minute without stopping to reload, sending 400 to 600 rounds downrange. A Type 92 needed to reload 20 times to fire the same amount, with each reload eating up precious seconds while under fire. Multiplied across thousands of battles throughout the Pacific, this firepower advantage became strategic dominance. Every Marine rifle company possessed machine guns that could control any battlefield. Every Army infantry battalion could establish kill zones that Japanese forces couldn't possibly cross. The M1919's reliability meant American forces could count on their automatic weapons anywhere. Jungle humidity, coral dust, volcanic ash, monsoon rain. Japanese soldiers knew their Type 92s might fail at critical moments, which affected both tactics and morale. The production figures told the ultimate story. 390,000 M1919s versus 45,000 Type 92s. That gave American forces overwhelming automatic weapons superiority at every combat level. It wasn't simply about having more guns. It meant having more reliable guns, more ammunition, more spare parts, and more trained personnel. The advantage multiplied across every dimension. More weapons firing more reliably for longer periods with endless ammunition created a firepower gap that no amount of courage could bridge. John Moses Browning's M1919 proved that thoughtful engineering combined with mass production could deliver decisive battlefield advantages. The .30-06 cartridge, launched at 400 to 600 rounds per minute through a reliable simple mechanism, beat the Type 92's precision engineering and intricate operating system. The capacity to maintain fire transformed killing into an industrial process that determined Pacific victory. For Japan, the Type 92's shortcomings reflected the broader struggle of fighting an industrial war with handcrafted weapons. The gun's weight, complexity, and failure rate were symptoms of a military that hadn't truly adapted to the industrial age. Meticulous craftsmanship that might have impressed during peacetime proved catastrophically inadequate against American mass production. The emphasis on individual marksmanship and accuracy couldn't compete with American volume and suppression philosophy. The Pacific War proved conclusively that modern warfare's outcome depends on delivering sustained, reliable firepower. American forces armed with M1919s created walls of bullets no amount of courage could overcome. Japanese forces armed with Type 92s found themselves consistently outgunned. Their precise but slow weapons couldn't match the sheer volume American automatic weapons delivered. The mathematical reality was stark. 400 to 600 rounds per minute from belt-fed guns overwhelmed 450 rounds per minute from 30-round strips. The human cost was almost incomprehensible. Japanese infantry assaults that might have succeeded against similarly equipped opponents were obliterated by American machine gun fire. Banzai charges that had worked against poorly armed Chinese forces became slaughter against American firepower. Tens of thousands of Japanese soldiers perished charging through kill zones dominated by M1919s. Their lives spent against an industrial killing machine they never could match. Ultimately, these two weapons told the Pacific War's entire story. The M1919 represented American industrial capability, practical engineering, and grasping what modern combat truly demanded. It was practical triumph over perfection, the useful over the theoretical, the industrial over the artisan. The Type 92 symbolized a nation's inability to wage industrial war with weapons designed for a previous era, built through methods meant for different volumes, and employed using doctrine from a different age. When American machine guns opened fire on Japanese soldiers running forward, the outcome was already settled by design choices made years before in factories on the opposite side of the world. The M1919 Browning had won its victory long before any battlefield engagement, becoming one of history's most effective military weapons. While the Type 92 became synonymous with Japan's failure to match American industrial warfare capability, the Pacific War ultimately came down not to bravery, both sides possessed that in abundance, but to the ability to manufacture reliable weapons, delivering overwhelming firepower. In that contest, 390,000 M1919s against 45,000 Type 92s said everything.